Hi everyone, welcome back. And in today's lecture, we will try to understand the architecture of the Linux. The architecture consists of following components like kernel. First of all, we will try to understand some more details about the kernel. Then we will understand the system libraries, compilers, package managers, desktop environment, and applications. So let's start. So let me explain some details about these points. A Linux operating system consists of multiple layers working together. At the bottom is the hardware layer. Above the hardware sits the Linux kernel. The kernel communicates directly with physical devices. System libraries provide interfaces that applications use to communicate with the kernel. Compilers allow developers to build software. Package managers install, update, and remove software. Desktop environments provide graphical interfaces, while applications provide functionality to end users. This layered architecture makes Linux highly modular, flexible, and maintainable. So let me explain these points with some more detail. Linux development moves very quickly and new kernel versions are released regularly. Some versions are designated as stable releases, while others receive long-term support, commonly known as LTS support. Organizations running production systems prefer LTS kernel because they receive security updates and bug fixes for several years. For example, many enterprise Linux distributions are based on LTS kernels because reliability is more important than having the newest features. And on my screen, I have shown some stable versions and some long-term support versions. Stable kernels focus on delivering the newest features, hardware support, and improvements. Long-term support kernels focus on long-term reliability and support. These kernels continue receiving updates for years after their initial release. A home user or enthusiast may prefer stable kernel to access the latest technologies, while organizations operating critical applications usually select LTS kernels to minimize risk and maximize stability. Enterprise Linux distributions prioritize reliability over cutting-edge features. For example, Red Hat 8 was built on kernel version 4.18. When newer kernel versions were available, this allows organizations to run mission-critical workloads on a thoroughly tested platform. Similarly, RHEL 10 is based on a newest LTS kernel that balances stability with modern hardware support. One interesting practical use by enterprise Linux distributions is called backporting. Backporting means taking a feature, bug fix, or security enhancement from a newer kernel version and adding it into an older stable kernel. At first glance, you might think that an older kernel lacks modern functionality. However, enterprise vendors such as Red Hat, SUSE, and Canonical often backport important improvements into their supported kernels. For example, RHEL may continue using a kernel version that is several years old while still providing many of the latest security enhancements and hardware support features. This approach allows organizations to benefit from modern improvements without introducing the risks associated with the upgrading to a completely newer kernel version. Backporting is one of the reasons enterprise Linux systems remain highly reliable while still staying secure and up to date. A Linux distribution provides much more than just the operating system itself. It also delivers a complete ecosystem of tools and services that help users maintain and manage their systems. One important service is package management. Package managers allow administrators to install, update, and remove software easily. Distributions also maintain software repositories that contain thousands of applications and updates. Security features and bug fixes are regularly released to protect systems against vulnerabilities and improve performance. Commercial Linux vendors additionally provide technical support, certifications, documentation, and compatibility testing. These services are particularly valuable for organizations running business critical applications where system reliability is essential. In short, a Linux distribution is not just a software, it is a complete support and maintenance platform.
So guys, we have completed the Linux architecture and core components part. If you have any queries, do let me know in comments and don't forget to like and subscribe and share it with your friends. Thank you.